In this documentary, we'll show you how three scientists have designed and built a homemade bioreactor to make great wine. Join us on the journey through the world of biotechnology and wine tourism. First of all, it should be clarified that a bioreactor is a device that allows the cultivation of cells under controlled conditions to obtain products of biological interest such as antibiotics, hormones, or vaccines. Bioreactors are used in various industries such as pharmaceutical, food, agricultural, and environmental industries, but they can also be made by hand with low cost and easily accessible materials. To make homemade wine in a bioreactor, you need a fruit that has sugars such as grapes. The juice is obtained from the pale fruit that is filtered and clarified. We add yeast to transform the sugar into alcohol and carbon dioxide through the process called polyfermentation. The three scientists who have designed and built a homemade bioreactor are Ashley, Bolivar, and Christian. They will explain more about how the bioreactor works and what benefits it has to make homemade wine in it.
Hello, Christian, Bolivar, and Ashley. Thank you for having us in your lab. Tell us what motivated you to this project.
We were motivated by curiosity to apply our knowledge to a traditional product like wine. We wanted to demonstrate that you can make wine at home using a bioreactor and that you can obtain a good quality product.
In addition, we were interested in exploring the possibilities of using different fruits, but in this case we chose grapes that have a high sugar content. We wanted to take advantage of natural resources and sustainable development.
Also, we thought it was a fun and creative way to learn about alcoholic fermentation process. We wanted to understand how physical and chemical variables influence wild yield and quality, and how bioreactor design and operation can be optimized.
Very interesting. And how does the bioreactor you have built work?
The bioreactor we have built as an air-life reactor, which uses air as the agitation and oxygen transfer medium. The air is injected through the bottom of the tank, generating an upward current of liquid bubbles, which are mixed and distributed homogeneously.
The bioreactor has a capacity of 2,000 liters and is made of stainless steel and resistant, hygienic, and easy to clean material. The bioreactor has a top lid which can be opened to introduce the wort and yeast, and has a stake valve which relates to pressure. The bioreactor has a jacket which filled with water and which is connected to an external cooling or heating system. The bioreactor has an internal tube connected to filter that retains the biomass and lets the fermented liquid pass to trunk, which is cooled in a wine bottle.
The bioreactor has an instrumentation system that allows measuring and controlling process variables, such as temperature, pH, alcohol concentration, etc. The bioreactor has a thermometer, a pH meter, a refractometer, a densimeter, and turbometer, which measures the biomass concentration of the liquid and which is concentrated to a controller, which regulates the aeration rate as required.
Good afternoon. Today we are joined by Dr. Amy, biotechnology expert. Dr. Could you tell us later about the history of the bioreactor?
Of course, bioreactors have a fascinating history dating back thousands of years. In ancient China and India, they were used to ferment foods and drinks such as wine, beer, and vinegar. During the Industrial Revolutions, bioreactors began to be used for the production of chemicals and medicines. It was a turning point in his development. With advances of biotechnology, bioreactors are critical in the production of pharmaceuticals, biofuels, and food. Additionally, with genetic engineering, they were used to produce therapeutic proteins and vaccines.
Without a doubt, your evolution has been impressive. How do you see the future of the bioreactors?
think they will continue to play a crucial role in the production of medicines and bioproducts, and it's exciting to think about the new applications that could emerge in the future.